So Namaste, this is Sunil from Hindran Engineering. Today we are yet at another site in Bangalore where we have installed a rooftop PV system. So this is a 15 kilowatt AC coupled hybrid PV system comprising of 25 panels of each of 600 watts and connected to the Enphase microinverter. This is a very special site in many aspects. Point number one, this is a site where we have actually installed battery systems with microinverters. That is point number one. Point number two is almost this entire home is actually powered by our Enphase PV system coupled with the Enphase battery system. Now I will run through the technical details of this installation and take you through a little bit of wiring and other kind of setups that we have done in this site. To start with, you have seen in our other videos that we have provided a walkway for cleaning purposes. This is a site where there is no walkway because the height of the structure is not too much. So it is easily accessible for cleaning. In fact, it was just cleaned about a couple of days back. So one could easily walk in the space and clean the panels. So 15 kilowatt of DC power comprising of 600 watts of PV panels, 25 panels in all, is laid out here in this layout. It's a three-phase PV system. So in the Enphase microinverter setup, these are actually single-phase inverters. So we'll have to wire this in a way so that the net output is a three-phase output. So it is branched accordingly. So we have branched the panels in such a way that we get a three-phase PV output. You can see here we have provided some terminal blocks here. There are some MCB switches here. So these are the combiner boxes where the microinverters are combined and output is taken down into our controller and the meter. So I have spoken earlier about microinverters. So one of the greatest advantages of this microinverter is it's a very, very safe system. So it's a DC safe system. It's an AC kind of a topology. So you can come down, you can see here, each of the panels have a microinverter each. So there are 25 panels. That means there are 25 microinverters. What it actually means is it is 25 independent, discrete power producing units. So none of them are dependent on each other. So say for example, you can see here, there is actually a tank here. It was inevitable. We could not move this tank, right? But this tank casts shadows on both the sides. In the morning, it casts on the western side. In the afternoon, it casts shadow on the eastern side. So these microinverters, which are adjacent to these panels, actually produce their own independent power. So they're not connected to the next microinverter in series. So any shadow on one panel has no bearing on the adjacent panel. That's one of the other advantages of this system. And of course, it's modular. If tomorrow, if you want to scale the system, it's very easy. Just add more inverters and more PV panels. So now, these inverters are actually, as I told you, it is wired in three phases, L1, L2 and L3. So L1 phase is connected to our battery system. So L1 phase actually has 13 microinverters. So 13 microinverters go into a backup circuit. The other 12 microinverters are connected to the non-backup circuit. So this is the layout. So in this entire campus, it's actually it's spread into two roofs. This is roof number 1 and roof number 2. So we have actually a small, this is the other side of the system. So here we have got 6 panels. The rest of them are mounted here. So now here, one of the reasons of going for solar for this site is, one, of course, there was a high electricity bill. We had to reduce the bill. Second is there was plenty of fluctuations and surges from the power utility company. So one of the reasons why we have installed a battery system here is to completely insulate the consumer from any kind of grid fluctuations or grid troubles. So I will now take you down and show you how this PV panels and microinverters are wired into our battery system and what is the capacity of the battery, some minor details about the battery wiring, and it will also show something about the kind of protections given in this system. So now the house behind me is actually completely powered by our solar PV system combined with the battery system that we have here. So we have an elaborate battery arrangement to actually take care of any kind of power outages and any kind of power fluctuations. So the PV system along with the battery completely powers the loads of the house. Now we will go in detail about how the PV is integrated into the battery and how the PV is integrated into the grid and how the grid is connected to our controller. We'll take you one step by one step. So now we are at the battery station. We have the battery here, we have the controller here. The entire power flow and the entire energy dynamics happens through this station. So before we go into detail of this, there are certain very critical housekeeping aspects that one need to take care of, particularly when they have multiple batteries. Point number one, the room must be well ventilated. See, in this room we have got two windows, cross ventilation here. There's a window behind this. There's also a window in front of me. So there is good ventilation. Also, in case we require, I would rather recommend we also have a ceiling fan so that this room is well ventilated and kept cool. Another important aspect, whenever we have got energy storage, we need to have a fire extinguisher installed, handy and pressurized, God forbidden, in case of any kind of emergency. Now we will start with the wiring details. I will briefly run through the wiring and the connections and how this is actually connected to power our load. So we'll start one by one. So I have opened up one of the boxes here. This is the first combiner box. So as I told you, there are 25 microinverters. So they are combined in this bus bar. So all of them are combined here and then given to one AC breaker. From here, the PV power goes into a generation side meter. Many utility companies actually ask for measuring only the solar generation. So this detail becomes very important. So before the PV is connected to the battery, we first have to meter it. So this is the first breaker combiner. Now we will just go down to the meter panel. I will show you the further protections given to the PV side. So we are at the main metering panel. As I told you, the PV generation has to be recorded through a separate meter. So before the PV gets into the meter, we have got some PV side protections. So on the PV side, we have got an ELCB. So we have a MCB. We have a ASPD also. So these are the protections given. From here, the PV output is given into a generation side meter. From here, it goes back into our controller. As I told you, we are also connecting the controller to our grid. So actually the grid integration happens at the controller. So even before the grid actually gets into the controller, we have also given some protection at this stage itself for the grid. So we have got a type 1+2 SPD and an MCB, and we have more protections on the top, which I will show you now. So now we have come to the battery station here. So as I told you, this particular site has got 4 batteries and 1 controller. We have got a 15 kilowatt of DC, that's 25 panels, 25 microinverters on the top. So we will start with the controller. This is called an IQ controller. This is actually the brain of the system. So all the connections happen inside this. So PV is connected inside this, the batteries are connected inside this, the grid is also connected inside this. So this actually has a microgrid forming capacity. So what is this microgrid feature and what is this battery configuration? What is AC coupling? We will try to discuss this in a little detail now. So this is a typical AC coupled hybrid PV system. So how does the system work here? So the consumer loads are first driven by the solar PV system. That's the solar panels on the rooftop drive the loads during the day. In case of any deficiency of energy, the balance can be drawn from the grid or the battery. So if the grid is not available, the IQ controller forms a microgrid. So the PV system starts driving the load. When the grid is available, we can also export the power back into the grid. Just to put it in other words, the PV system first drives the load. In case of any shortfall of energy, the balance can be drawn from the grid if the grid is available. If there is excess energy produced during the day, the excess energy first charges the battery. If there is any further excess energy available, that is exported back into the power utility grid through a net metering arrangement. In a conventional on-grid system, what happens is when there is a power shutdown or if there is a grid utility failure, the PV system also stops. In a hybrid system or an AC coupled system, the IQ controller makes a microgrid. It detects the failure of the grid automatically, forms a microgrid, and the PV starts powering the load in case of a grid outage. Say the power requirement is more than what the PV can produce. The balance can be catered from our batteries. These batteries are AC batteries or AC coupled batteries. I will just explain about what is AC coupling in a while. So that's about the hybrid configuration. So in the evening when there is no sunshine, the loads can be either met by the grid if the grid is available. If the grid is not there, we can also drive our loads from the battery. We can also set the battery percentages to drive for a certain amount or a certain voltage or a certain percentage of loads can be taken from the batteries and then it can switch to the grid. This is highly programmable. I will show it to you how these things can be done. First, let me open up the IQ controller, just give you a little bit of detail about the wiring inside and then explain about the battery. Let me just open this up first. So this is the IQ controller. This forms the brain of the system. So essentially this has got terminals inside for connecting our PV grid and the battery, and this also delivers single phase power output. One of the features of this is we have a cellular modem, a backup data pack in case the home internet fails. So we have got some protections here. We have got the relay, we have got MCBs, and we have got certain inbuilt relays. Let me open this front deck and show you the terminations. So we have opened up the front deck here. So as I told you, this forms the brain of the system. So there are terminations here for all the wirings, all wiring, internal wiring is already done. So we have got our main PV system through a breaker is connected here. So this can take 3-phase PV. It can also take 3-phase input from the grid. So the 3-phase input from the grid is also given here. There is a 3-phase input from the PV side. We can also connect the non-backup loads into the same controller, and it delivers single phase of power for the backup loads at maximum of 63 amperes. So backup loads is 63 amps. That is going through some protection and into the load. And as I told you, this actually forms the microgrid when there is a grid outage. So all the controls are inside this. So when there's a grid failure, this automatically detects the grid failure and there's a seamless transition into the microgrid. In the microgrid kind of configuration, the PV and the battery together run the loads. We also have a gateway here. This gateway is actually very important. There is pre-installed current transformers. So through this gateway, we can monitor every parameter of the system. We can monitor the live production, live consumption. We can get the data charge, discharge of the battery. We can get the battery health. We can see what is the amount of energy stored in the batteries, what is the power available. Every kind of parameter can be tracked through this gateway. So this forms the heart of the system. So now we have got 4 batteries. So we will see how these 4 batteries are connected into our controller. So each of these battery is a 5 units battery. At maximum, it can deliver 3.84 kilowatt of continuous power with a 200% inrush. That is, it can go up to 7.5 kilowatt for a brief period of time if required. So each of them is 3.84 kilowatt and each of them can store 5 units. So totally we have got 20 units of energy stored in this battery. and approximately 15 kilowatt of power also stored here. So let me open at least a couple of these batteries and explain to you about the AC coupling configuration here. Let me just open the battery now. As I speak, actually there's a power cut, so the system actually has shifted to the off-grid mode, but actually the PV is driving the energy requirement. So I've just opened up two batteries out of the four. So I have spoken to you earlier about this battery. In that side, we have just one battery connected to the one controller. Now we have got we have got four batteries. So we have opened up two batteries here. So this is perhaps the most safest available battery as of today. And this is the LFP chemistry, that is the lithium phosphate chemistry. That is very, very safe because it doesn't get very hot. It is non-combustible, non-toxic, does not use any harmful material. So this makes a very safe bet for a household kind of an application. And this can store 5 units or 5 kWh of energy, can deliver 3.84 kilowatt continuously with a 200% inrush. So as we have got 4 of these batteries, we have got 20 units of energy stored in this system and 15 kilowatt of power. If required, it can also be increased. It's so modular that we can increase more batteries if required. And it can also give you some kind of a surge, like the inrush. Say for a brief period of time, we have a peak power requirement. This can deliver 200% for a very brief period of time. This is an AC coupled battery or an AC battery. That is, in a conventional hybrid system, we have only one set of inverters. In an AC coupled system, we have got 2 sets of inverters. One is called the PV inverters. In this case, it's a microinverter on the rooftop. This is the other set of inverters called the battery inverters. So how does the power flow happen? The DC of the solar panel is converted to AC right below the solar panels. And that AC is again converted to DC to charge this battery. And there's this DC is converted to AC to power our application. So in this case, there's an additional advantage. The battery also contributes to the load during the daytime. To put it very briefly and simply, say the PV is generating 4 kilowatt of energy, plus we again have 3.8 kilowatt in the single battery. Totally during the daytime, we can run 4 plus 3.8, 7.8 kilowatt of power during the day. In this case, we have got 4 batteries, so 4 into 3.8 plus whatever is the PV is generating. In a DC coupled system, this is not the case. In a DC coupled system, the net power output is equal to the inverter output. That is, whatever is the 4 kilowatt inverter, 4 kilowatt is maximum what we can actually draw. So it's an additional advantage with an AC coupled system. AC coupled system is also modular, as I told. Tomorrow, if you want to add more batteries, we can still add more batteries. So now I will talk about how this battery and the grid is connected to our IQ controller. So each of these battery has got a phase and neutral and an earthing connection and a communication cable. So we have drawn exclusive wires, cables from each of these 4 batteries because it is safer to do that. And we have combined all the batteries in this battery combiner box. So here we have a box. We have got 4 batteries. So we have got 4 breakers of 20 amps each. The output of the breakers is terminated into a bus bar. In the bus bar, we again have a MCB. And this MCB output is connected to our controller. So this is how the battery is connected into the controller. This is another breaker for the battery. So 4 batteries, 4 breakers, bus bar, and another 2 additional breakers to connect into our controller. So each of these battery also runs a communication cable. So we take parallelly the communication cable from one battery to the other battery, this battery to this battery in a certain configuration, and finally we terminate the communication cable here. So it's a very, very simple, safe. As you see, the battery wires is just 6 square mm. See, unlike a conventional lead acid battery or any kind of other kind of batteries where we require thick cables, this is very easy to install, easy to maintain, because even the cable cross sections are little lower. So that's about the battery. So now this house, predominantly morning loads are taken care by the PV panels. We are actually discharging a little bit during the evening and then again connecting it to the grid so that there's a battery is charged. But the system is designed in such a way that the house can be completely off grid. That is another feature of this system. Here we can actually choose our configuration. There are 3 configurations available. One is called self-consumption mode. In self-consumption mode, we can set the SOC, that is the state of charge, and we can adjust it so that our grid dependence goes down. Second is a full backup mode, where the system acts like a UPS, where the battery is always charged. We go for that settings when there is a too much power cut, or there is prolonged power cut, or if there is a heavy requirement of energy at the house. There's also a savings mode where we can actually shift to the battery configuration at the peak power tariff regime. That is not applicable as of now for households in Bangalore, but as and when it comes, we can actually shift to that mode. So it's highly programmable, highly very, very user friendly, and everything can be actually monitored, controlled by our cellular phone. So that's about the battery. As I told you, this can also connect the grid. Rather, we have to connect the grid inside for net metering arrangement. So the grid also comes through another protection box. So we have got another box here. So the grid also goes through one. I showed you down. There was a MCB and an SPD. We have got an additional MCB, additional ELCB, and this is connected into our controller. So this controller basically takes in input from solar PV panels, takes input from the battery, can take input from the grid 3-phase at 63 amps at each phase. We can also connect the non-backup loads for monitoring purpose. The backup loads is given through single phase. That also goes through the SPD and further goes to our load application. So this is briefly about the system here. There is one very important additional feature here, that is this rapid shutdown switch. See, now we have got so much of power flow happening and we have got so many wires coming in and coming out. God forbid, if there is any kind of emergency or any kind of requirement where the entire system has to be shut down, the PV, the grid and the battery, everything, we just have to turn this switch. This is very important. It's mandatory in many of the countries for firefighting applications, but this is installed here. This is an emergency switch. If we turn it off, the entire power infrastructure here shuts down. That's an additional feature here. Plus, we also have a bypass switch inbuilt here. For some reason, if there's a battery failure, we can always bypass it and run the loads through our DISCOM power. So this is about the hybrid system that we have installed here. This is, of course, 4 batteries, 15 kilowatt of solar DC power, 25 microinverters. Each of these batteries have again 6 microinverters each, so that again there's 24 microinverters here. There are 4 battery setups and there's an elaborate safety or rather protections given to each of the circuits. So that's about the system here. Hope this was helpful. Thanks for watching.